Alright, welcome to Colossus Mathematics class. Don't forget to subscribe, like and share this video. In today's class, we are going to be talking about the product and the quotient rule in differentiation. Don't forget that we've been teaching on differentiation. So if you've not seen my previous video, do well to watch this video to the end so that you can see the link to those videos, or you check the comment section, the description of this video, so you can watch those previous videos. All right, so in today's class we're talking about product rule. Now this product rule says that if y is equal to what, uv, where u is with respect to x, so sometimes they can write like this: y equal to what, u of x v of x. I get what I'm saying. So this is what we mean by this statement. All right, so if they are a function with variable x, then our dy dx, to get our dy dx will be what, v du dx plus what, u dv dx. And the same thing goes for the what, for the quotient rule. Quotient, when we talk about quotient, it deals with what, with fractions. I get what I'm saying. It's dealing with fractions. So that's it says that if y equals to what, u over v, then the quotient rule states that what, dy dx will be what, v du dx minus what, u dv dx all over what, v squared. Very simple. Are you seeing that now? So let's see example. Let's see the first example under product rule. Are you seeing that now? Let's see the first example under product rule. So let's say we have a question like, let's say we have given that y equal to what, sine 2x multiplied by what, 5x plus 2. Are you seeing that now? If this is a question that you have here, you can see from here now, you can say that, so what you are going to say now, you can see that this is a function on its own, this is another function on its own. So what you are going to use is, you are going to use the product rule. So your u here is what, sine 2x, and your v is what, 5x plus 2. Are you seeing that now? So now you have to differentiate. So your du dx, differentiating u with respect to x, your du dx is what, differentiate sine 2x. If you differentiate sine 2x, what will you get? I've done this before in my previous video, but now I'm going to show you the shortcut. You can also see the link to a full shortcut of this thing. If you want to do this now, what you are going to do is differentiate sine. If you differentiate sine, you get what? You will get cos. Are you seeing that now? So let me repeat that. Let me do it in a simple way. What you do first is differentiate 2x. If you differentiate 2x, what will you get? 2. Then now differentiate sine. What will you get? You will get cos. Then write your 2x back. So that's 2 cos 2x. Are you seeing that now? Alright, so our dv dx now, differentiating v with respect to what, x now, dv dx. Our dv dx will give us what, 5. Are you seeing that now? You will get 5. Do you understand? Alright, so now after that, the next thing is to put it into your formula. Don't forget your formula, dy dx, because that's what you are looking for. Your dy dx is equal to what, v du dx plus what, u dv dx. So that will now give us what was our v. Our v is what, 5x plus 2 multiplied by our du dx. What's our du dx? 2 cos 2x. Are you seeing that now? Plus, what's our u? Our u is what, sine what, sine 2x, then multiplied by our dv dx, which is what, 5. Are you seeing that now? So open this bracket. That will be what, 2 multiplied by 5x. You see, anything is the one in front, at the back of the cos, that will be multiplying this 2x. Nothing will happen to this 2x. Are you seeing that now? So it is only these ones that will be affecting. So 2 times 5x, that will give us what? 10x cos 2x. Are you seeing that now? Then 2 times this, that will also give us what? 4 cos 2x. Then what? Plus 5 multiplied by sine 2x, that will give us what? 5 sine 2x. Are you seeing that now? So that is the answer to this question. Now let me do it. Let me say we have the question again, like number 2. Let's say we have y equal to what? Sine 5x, sine 2x rather, sine 2x over what? Over 5x plus what? 5x plus 2. So let's say the question is in form of quotient now. Are you seeing that? If the question is in form of quotient, so this is our what now? This is our u and this is our what? Our v. Are you seeing that now? So your u is equal to what? Sine 2x. Are you seeing that now? Your u is equal to what? Sine 2x, and your v is what? 5x plus what? Plus 2. That means your du dx, we've differentiated something like this before. Your du dx is what? Is 2 cos 2x. Are you seeing that now? And your dv dx is what? Is 5. Are you seeing that? Now what's your formula? Our formula for our dy dx is what? V du dx minus, are you seeing that now? Minus what? U dv dx all over what? V squared. And if you apply that, what's your v? Your v is what? 5x plus 2. No, I'm not sure it will contain that side, so let's do it in this bigger space. Don't forget to subscribe, like and share this video. So your v is what? Is 5x plus 2. Are you seeing that? Multiply by what's it called? Multiply by du dx. What's your du dx? Your du dx is what? 2 cos 2x. So this is what? 2 cos 2x. Are you seeing that now? Minus your u is what? Sine 2x. Then multiply by your what? Your dv dx, which is what? 5. Are you seeing that now? So this will now give us what? Over our v, which is what? 5x plus 2 all squared. Now some mistakes students used to make. Some people will now say that what? Some people will say this one cancel this one. No, it is not possible. They cannot cancel that because it is not a common factor. So don't do that. Don't say they cancel out. It is only when they are a common factor that you can cancel out. So in this place, this can be your final answer. I get what I'm saying. This can be your what? Your final answer, or you can work further by opening the brackets. That's just like what we've done here. I think that if you open the bracket, you are going to have something like this. This one will just be negative. That's the only thing that will happen here. So this will be what? 10x. As I've told you before, 5x times 2. That's 10x cos what? Cos 2x. Then what? Plus 4. Are you seeing that now? Because 2 times 2 is 4. So plus 4 cos 2x. Then what? Minus what? Minus 5 sine what? Sine 2x. Then all over what? Your denominator, which is what? 5x plus 2 all squared. Do you understand that question now? So that is how you do a question like this. Are you seeing that now? That's how you do a question like this. So let's another example. Let's say I have y is equal to y is equals to, let's say y equal to exponential 2x. Let me not use 2, let me say exponential 3x cos exponential 3x cos 7x squared. So let's say this is a question now. I think that if you want to differentiate this, how will you differentiate it? Very simple. So you can see that this is product because they are multiplying each other. So your u here is what? Is exponential 3x. I think that now your v is what? Cos 7x squared. I think that now. So if you do your du dx here, du dx, I've told you something like this in the previous videos. If you do your du dx here, this will give us what? 3 exponential 3x. Don't forget, I told you that if you differentiate exponential kx, it will give you what? K exponential kx. I told you. Alright, so that's how we got this 3 exponential 3x. And then your dv dx, if you differentiate dv dx using the shortcut I teach you in the last example here, don't forget the example, the shortcut I did here. I seen that the shortcut I did here, differentiate this first, 2, differentiate sine cos, and then write the 2x back. I seen that now. So that is what you are going to apply here. So I'll differentiate 7x squared. If you differentiate 7x squared, what will you get? You will get 14x. I seen that now. Open bracket, multiply by differentiate cos. If you differentiate cos, you will get what? Minus sine. That's why I put it in bracket. I get what I'm saying, so that you would not mix it together. I think, if I write 14x minus sine, you will think it's different thing. So that's why I write it in bracket. If you differentiate cos, you get what? Minus sine. Then write your 7x squared back. 7x squared. I seen that now. So that means our dv dx is what? Minus 14x sine what? Sine 7x squared. I seen that now. So now let us now apply our formula. Our dy dx is equal to what? V du dx. I think that v du dx plus what? U dv what? Dv dx. I think that now. So that now give us what? What's our v? Our v is cos 7x. So this is what? Cos 7x squared. I think that now. Multiply by your du dx. What's your du dx? This one. So multiply by what? 3 into bracket what? Exponential 3x. I think that now. Then what? Plus, what's your u? Your u is what? Exponential 3x. I think that now. Multiply by your what's it called? Your dv dx. This is your dv dx here. So that's minus 14x sine 7x squared. I think that now. So if you multiply the bracket, you are going to have this times this. That will give you what? 3 exponential 3x cos 7x squared. Don't forget, I told you that nothing in front of cos can be multiplied. Then plus times minus. That give us what? Minus what? 14x. Then this exponential will enter it. Exponential what? 3x. Then what? Sine what? Sine 7x squared. So in case you don't understand what I did there, it's a very simple something. I get what I'm saying. This is what I did. Minus multiply by plus will give us what? Minus. Abi. Then 14x multiply by this. That will give you what? 14x exponential 3. Then sine. It will nothing will disturb it. Alright. So now let's see the quotient. let's say we have the question to as quotient, y equal to what? What's the one up there? So let's say it as let's write it as y equal to what? Cos 7x squared over exponential 3x. Are you seeing that now? If you want to do this now, what's your v? You already know that this is your u now. In this case, this is your u and this is your what? Your v. Are you seeing that now? You already know what your du dx will be. Your du dx. So your du dx, if you differentiate your u, you already know the answer you will get now. I'm sure you already know the answer we'll get. That's minus 14x sine what? Sine 7x squared. So this was minus 14x sine 7x squared. Abi, then what will be your dv dx? You've also done that. Dv dx, if you differentiate it, that will give you what? 3 exponential what? 3x. Are you seeing that now? All right, so let me say this. In this our previous example, this particular example, you can still solve further by saying what is common among them. Exponential 3x is common among them because it is here, it is also here. Are you seeing that? So into bracket, if you take this out here, it will remain only 3 cos 7x squared. Then what? Minus what will remain here? It will remain what? 14x sine what? Sine 7x squared. So I just need to say that so you can remember. All right, so coming to this one now, so we already have every value we need. So our dy dx now, our dy dx will now be what? V du dx minus what? U dv dx. I think that u dv dx over what? Over v squared. Are you seeing that now? That will now give us what? What's our v? Our v is what? Exponential 3x multiplied by du dx. What's your du dx? Minus what? 14x sine what? Sine 7x squared. Are you seeing that now? Minus what's your u? Your u is what? Cos 7x squared. Are you seeing that now? Multiplied by what's your dv dx? Your dv dx is what? 3 exponential 3x. Are you seeing that now? All over what? Your v squared. That's exponential 3x all squared. Are you seeing this now? So now if you look at this numerator, something is common there. Exponential x is here, exponential x is here. So you can see that exponential 3x is common among them. Are you seeing that? That means on this side that we have with what? Minus 14x sine 7x squared. Are you seeing that now? And then this is what? Minus, this will remain 3, then multiply by this cos. So 3 cos what? 7x squared. Are you seeing that now? All over what? Exponential 3x multiplied by what? Exponential 3x. You know it is still the same thing. I'm sure you know now. Square means writing it 2 times. Now the reason why I did that is because if you look at this, this place, you can see that I have factorized exponential 3x outside. This is what I was saying in the other example. If you look at the other example, we have something like this. No, not this example. This particular example, you know, I said this one cannot cancel this one because you do not factor anything out there. Are you seeing that now? You do not factor anything out. But if you look at this, our particular example now, we factored out this already. So that means this one can cancel one of these. Are you seeing that now? That means our final answer is what? Everything here over exponential 3x. So our final answer is what? Minus 14x sine what? Minus 14x sine 7x, no mind me, sine 7x squared minus 3 cos 7x squared, 3 cos 7x squared all over exponential 3x. So that is your final answer. Do you understand that now? Alright, so if you have questions, feel free to ask in the comment section, right? So these are the examples we looked into today. Don't forget to subscribe, like, and always share this video. Thank you very much for watching. So before we go, let me give you an assignment. So use anyone. So solve this. Number one, solve y equal to what? X raised to power 3, then 2x plus 1 all raised to power 3. Now you can see that you have to apply chain rule in this place. So if you have not watched the video on chain rule, do well to watch it. Number 2, so let's say the same thing. Y equal to what? X raised to power 3 over 2x plus 1 all raised to power 3 also. So do this first one, do this first, then number 3, do y equal to 1 minus x squared, 1 minus z squared sine 5x, so that's the first one. Then the last one, so just do y equal to what? 1 minus x squared over sine 5x. So do this 4 as assignment and then submit. So in the next video we are going to be looking at the application of differentiation. Thank you very much for watching. Don't forget to subscribe, like, and share this video. All right.